Hey everybody, this is just a quick video to kind of show you there were these two slides, this one and this one in the last video that I just wanted to basically show you how we could use like Desmos or Math3D to kind of get an idea of what something might look like. If you use Math3D for something that's 3D, we're going to be able to actually see it well, but you could actually use Math3D in the way I'm about to get an idea of what a four-dimensional thing might look like. If you do these like level, in that case it would be surfaces, but you can also do level curves in 2D to get an idea of what something looks like in 3D. So let me go back here. So I got this level curve, and I just basically made z equal 4 in this case, but if you change it, to 6 or 60 or whatever, you're just going to get different size circles here. So this is when, c equals 0, you just kill off this x, y, c term, and then you're going to just get circles, right? And so you got to kind of think about what, 3D object would have like cross sections that look like circles. And it's probably not too hard to think that it would be something like this. So, this is a circular paraboloid. And, if you just cut it, like horizontally here, across, you're going to get circles like this, right? And then you can try, sliding this. And you can see that if you slide it, it starts to form an ellipse, and it can kind of, whoops, I didn't want to go that far yet. But you can get ellipses, and it actually has a cutoff point at -2. And -2, on the left side at least, it has a cutoff point. You get this weird, these two parallel lines. And this one's kind of tricky, I think, to think about what it would look like. If you go up into the positive numbers, there's going to be another cutoff at 2. You get another set of parallel lines. And here it's probably not too hard to think that like you're basically getting, instead of a circular paraboloid, you're getting like an elliptical paraboloid. And that really is what you get. Like if I slide this a little bit, here you get elliptical paraboloid when it's set to 1. And if you go to the negative, you get that too. Probably the only one I think that's like really tricky is if you make this a 2, then it's hard to kind of envision maybe what that would look like. But you might have actually seen it because I just passed it. If it's set to 2, so you actually, the reason you're getting parallel lines is because it's like an infinite parabola like that. So it's like a cylindrical parabola surface that just goes on and on and on forever. Yeah, it looks like weird and pointy, but it wouldn't be pointy like that. It's just the way that this thing graphs it. And if you go to -2, you're going to get the same thing. I just passed it again, but it's just going to point in a different direction. And then you could see that as you go up into higher values, you just get different hyperbolas. So you would kind of think like you get a hyperboloid in 3D. And if you go into the negatives, you're going to get the same thing. You're going to get hyperbola shapes in 2D, which would mean that you're getting something like a hyperboloid in 3D. And that really is, I think you kind of already saw it. So if I let this thing go, up into higher values, you get hyperbolas there, hyperboloids there, and same thing here. See a little better there. If you want to do this in Math3D, if you just hit Add Object and then Variable Slider down here, that's what I'm using to do this. And I just changed this to A, and then I put an A in right there, and then it lets me do it. You can also then do fun stuff like this. You can let it kind of map through all these different ones if you just hit play. Makes your brain kind of hurt if you look at it. It also makes my computer not happy because this, I guess, is hard to render. And I won't spend super long doing this on the other one, but you can do this for the other one as well. So if I, you know, so this is set to C equal, or A here equals 1. Basically, because it's e to x squared plus y squared, you get kind of a circular exponential thing. And it basically, it really is a circle. Like if I switch over here and I do C equals 1, you can see it really does look like a circle right there. And I can get, ellipses. Basically what's happening with this one is you're kind of curving, like, because of the exponential, you sort of, do this in the video, you sort of curve the sides of it up. And so if, if you let A be, so this is what I wanted. So if you let A be like negative, then it's going to sort of curve the sides here in the x. So this is the x-axis. The sides in the x direction here and here will sort of start to like exponentially be pulled down because you're going to have, you're going to have a negative in there, and it's giving you that hyperbolic structure, but it's getting kind of like asymptotically flat. Like if you go further and further down, it basically will flatten it more and more and more in the x direction. And like if you go, and there was this one spot right there. So if A was 0, right, then you would get just e to the y squared. And that would be, some sort of exponential. So it's up, and then it's y squared, meaning you have just this no restriction in the x anymore. And so you're going to get like an infinite cylindrical structure where it's curved up in the y, but infinite in the x. And all of that can be seen with traces here too. Like this is the one where it's kind of hyperbolic. And then right there, I can't get it. Right there is the cylindrical kind of case. And basically as you make this thing bigger, then you are curving up in the x, you sort of pull it up more and more and more. And that's why this weird, it kind of gets like flattened. So like as I press play, you can see it's like curving on the x direction and sort of smushing it. And like actually if we zoomed in, it's not going to be able to do it well, but it's actually going to have some, oh boy, it jumped, that's why. It would be like infinitely thin here because it's curving it up and up and up and up and up and up. But it'll actually never touch. But this thing would never be able to render perfectly how close it gets. So hopefully this kind of gives you an idea of how we can use these traces. So, I wouldn't never ask you to graph something like this, but you can get ideas of what these look like in higher dimensions if you just make like the output variable a constant. And like if I change this one to like, I don't know, 10 or something, it's just going to change, some of the sizes a little bit, but it's not going to change the structure of the thing. But yeah, we use this to basically get an idea of what things look like in higher dimensions. And you can actually use Math3D to get an idea of what a 4D thing would look like if you did level surfaces here. So that's kind of a cool thing you can do too.